Hi guys, welcome to the fourth section working with the hyperlinked APIs in Django. In this section we will start with declaring relationships with the model. Then we move to managing serialization and deserialization with hyperlinks. We will then create class-based views and work with the endpoints for API. Lastly, we will create and retrieve related resources. Now we move on to the first video of this section that deals with declaring relationships with the models. In this video, we are going to take a look at creating the game category, players, and player score models. Then we will download and install PostgreSQL database. We will create the models that we are going to use to represent and persist the game categories, games, players, and scores and their relationships. Open the game's models.py file and replace its contents with the highlighted code. The highlighted code shows the new code that we have added to models.py file. We have declared the four models, specifically four classes, as subclasses of the Django.db.models.model class: game category, game, player, player score. Django automatically adds an auto-increment integer primary key column named ID when it creates the database table related to each model. We specified the maximum lengths and defaults for many attributes. Each class declares a meta inner class that declares an ordering attribute. The meta inner class declared within the player score class specifies -score as the value of the ordering tuple, with a hyphen as a prefix of the field name and ordered by score in descending order instead of the default ascending order. The game category, game, and player classes declare the _str_ method that returns the contents of the name attribute that provides the name or title for each of these models. So Django will call this method whenever it has to provide a human-readable representation for the model. The game model declares the game category field. The highlighted lines uses the models.foreign key class to provide a many-to-one relationship with the game category model. The game's value specified for the related _name argument creates a backwards relation from the game category model to the game model. Whenever we delete a game category, we want all the games that belong to this category to be deleted too, and therefore we specified the models.cascade value for the onDelete argument. The player score model declares the player field. The highlighted line uses the models.foreign key class to provide a many-to-one relationship to the player model. The scores value specified for the related name argument creates a backwards relation from the player model to the player score model. This value indicates the name to be used for the relation from the related player object back to a player score object. Now we will be able to access all the scores archive by a specific player. Whenever we delete a player, we want all the scores achieved by this player to be deleted too, and therefore we specified the models.cascade value for the onDelete argument. The player score model declares the game field. The highlighted lines uses the models.foreign key class to provide a many-to-one relationship to the game model. In this case, we don't create a backwards relation because we don't need it. Whenever we delete a game, we want all the registered scores for this game to be deleted too, and therefore we specified the models.cascade value for the onDelete argument. We finally save the file. You will have to download and install a PostgreSQL database in case you aren't already running it in your computer or in a development server. You can download and install this database management system from this web page. You can download the Postgre app from this website. We make sure that the PostgreSQL bin folder is included in the path environmental variable. Run the command to use the Postgres user. We type the password for user Postgres. We will use the PostgreSQL command line tools to create a new database named games. Run the command to create a new database named games. So now the new database games has been created. We can verify that by typing this command. As you can see, the first line shows that the new database game has been created and the owner is Postgres. Run some SQL statements to create a specific user that we will use in Django and assign the necessary roles to it. First, we will create a new role with login and password. Replace username with your desired username to use in the new database and password with your chosen password. We will use the username and password in the Django configuration. We can verify by typing the command. As we can see, the new role test1 has been successfully created. Now we will grant all the privileges to the role test. Run the command to verify it. As you can see, the access privileges are provided to the role test1 for the database games. We type /q to quit the PSQL command line tool. Open the game's API settings.py file. The highlighted part is default, SQLite database engine, and the database file name. In case you decide to work with PostgreSQL instead of SQLite for this example, replace the declaration of the databases dictionary with these lines. The highlighted lines are added. The nested dictionary maps the database name default with the Django DB backend's PostgreSQL database engine, the desired database name, and its settings. In this case, we will create a database named Games. Make sure you specify the desired database name in the value for the name key and that you configure the user, password, host, and port based on your PostgreSQL configuration. First, we will replace the username with our desired name, that is test1. Then we replace password with one we choose. Host and port are left as it is. When all the changes are done, we save the file. In case you decided to use PostgreSQL, it is necessary to install the scopg2 package. Once we have made sure that the PostgreSQL bin folder is included in the path environmental variable, we just need to run this command to install the package. The last lines of the output will indicate that the scopg2 package has been successfully installed. Now run the Python script to generate the migrations that will allow us to synchronize the database for the first time. First, we need to navigate to the game's API folder inside Django. We open the game's API games migration auto.py file. The highlighted lines show the code for this file that was automatically generated by Django. The code file for the sample is included in the RESTful Python section 0203 folder. The code defines a subclass of the Django.db migrations.migration class named migration that defines an operations list with many migrations.create model. Each migrations.create model will create the table for each of the related models. Django has automatically added an ID field for each of the models. The operations are executed in the same order in which they appear in the list. Now, run the Python script to apply all the generated migrations. These lines show the output generated after running the Python script command. Now we run the command to list the generated tables. Then we have to type the password for user test1. The output shows all the generated table names. Django uses the games _ prefix for the 4 table names related to the games application. Django's integrated ORM generated these tables and the foreign keys based on the information included in our models. Games _ game persists the game model. Games _ game category persists the game category model. Games _ player persists the player model. Games _ player score persists the player versus score model. The command will allow you to check the contents of the 4 tables after we compose and send HTTP requests to the RESTful API and make CRUD operations to the 4 tables. The commands assume that you are running PostgreSQL on the same computer in which you are running the command. Now we type the next command, that is select all from games game. Now we type the next command, that is select all from games player. Now we type the next command, that is select all from games player score. Instead of working with the PostgreSQL command line utility, you can use a GUI tool to check the contents of the PostgreSQL database. Django generates additional tables that it requires to support the web framework